Good morning, good evening, good afternoon. Hello and welcome everybody. And yeah, thank you for joining Discovering Neo4j AuraDB with Michael and Alexander. Hi, Michael. How's it going?
Hey Alex, how you doing?
Good.
How
Good.
was your weekend? Yeah.
It was good. I was family trip to Stuttgart to my niece and nephew.
Ah, nice.
Yeah, now back. So
Seeing the
yeah,
kids grow is always impressive, right? So how quickly
yeah,
they
that was
kind of
good.
grow and get new skills and everything. And especially if you see them only once in a while in person, then
Yeah,
the jumps are much more pronounced as such. It's true.
that's very true. Yeah, yeah.
It's
Was
been
good.
some
Was nice.
time since we saw each other last, right? So it's been 2
Yeah.
weeks or so.
But I didn't grow, unfortunately.
Yeah, and I'm only shrinking. um, yeah, it's been a busy 2 weeks actually, right?
Yeah. You've been to FOSDEM.
Yeah, I had lots of fun at FOSDEM. So actually, we had an if you want to put it on the screen, we had an graph algorithms and systems dev room, so which is kind of the name for their tracks. And we had a number of really good talks. Some of them had Neo4j content, some were more visualization related, some had other databases as well. So each of them is basically available with slides and recordings. And so for this one, I think they had like a problem with the recordings, but for the other ones, like this one here, detective about European procurement data. So here you see the video already embedded. So the sessions were well received, and the room was always full, so which was great. And then we spent time also to go to other dev rooms, like the Python dev room or the Rust dev room as well. And so that was pretty good. And I met some old friends and Neo4j colleagues like Nigel and Ryan and
Very good.
Which was really cool. And I chased a bunch of thieves across Brussels to get my backpack back with my computer and stuff.
Well,
that was quite an adventure. Yeah, so that was a busy weekend. But the other thing that we did last week, actually, we migrated our forums back to Discourse, which is really important because after migrating off Discourse last year, over the months, we got like lots of negative feedback that people didn't like the new forum and it was not good for technical content, and people were not kind of super hyped to be there and answer and help people. So we made the decision to move back to Discourse, and it's already looking good in terms of like engagement, people asking questions, and so I think everyone is pretty happy about that as such. If you spot anything that's off, please let us know. Because it's been freshly migrated back, and it was pretty complicated to turn HTML back into Markdown for Discourse and fix the attachments and comments and things like that. I think we still have to migrate likes over. So the last year of questions doesn't have as many likes as you would expect. So that's the only thing I think that's left to migrate over, and then fix some UI and CSS things, and then we should be good to go.
Yeah, and then we can take care of the rest. So if you spot anything, like Michael said, if you have suggestions, obviously, what you would expect, what you would like to see, what you're missing, what you find maybe complicated or whatever, then please also let us know so we can make this a space for everybody that fits the needs.
Exactly, and depending if you're more into forums or chat, you can also go either if you have questions or want to help other people, you can either go to the forum or go to Discord and help people there. So there's a lot of questions, and we also see happening now. Actually, it has live event things here. That's so cool. Thank you for adding that. And so we have almost 6,000 people now on Discord as well, which is great. And people are asking a lot of questions, and so if you want to, you can also come and ask, but you can also come and help others and answer questions as well. So I spent a bit of time over the weekend and last week to answer some of the questions on Discord as well. So feel free to check out either the forums or the or Discord as such.
Yep, exactly. Hi, Luca. Welcome to the stream. Thank you for joining. All right, so this is discovering AuraDB free with Michael and myself, Alexander. So just to give a quick overview of what's going to happen in the next, let's say, 55 minutes or so. I do a quick recap of what Neo4j AuraDB free is, if you don't know. And then we go into the flow. It means we pick a data set. As ever, if you have something you see and you find interesting, but you don't dare yourself to dive into it, or you think, okay, this could be interesting for a wider audience, could be a Kaggle data set, could be something you have, obviously, the rights to share as well, could be something you see somewhere as an article or something, and you say, hey, this is interesting, then let us know, give us a ping, and we have a look at it. And then from this data set, we work a little bit around, okay, what could be interesting questions? We have a look at the data set, and analyze it a little bit, and then we determine the data model, and then we build that data model as a graph data model, and then we import it into the graph database and write some initial queries to play around a little bit with the data. So, and all of that, the goal is to be done in an hour.
Yep. That's always the challenge, right? It's because you always run over.
Yeah, we run over a little bit, but usually we get there pretty
yeah, and it's a good starting point as well, right? So we get you to a certain degree, and then there's lots of stuff that you can do with the data set later. So that's I think it's a good starting point, and it gives you kind of the initial setup, how to get the data in, and then from there you usually can take it further as such.
Exactly. So if you want to either later or now code along, then you need an Aura instance if you don't have one yet. So this is the link is in the chat as well. Go there. It's free. And what does it mean? You get it for free means you just have to log in with an email, assign a password, a username, basically, and then you get a full enterprise edition of Neo4j. But in the cloud as a service, basically. The limitation is that it is cut down to 200,000 nodes and 400,000 relationships. So if you want to, if you need more space, have a bigger data set, want to work with bigger data, then you need to upgrade to Pro. But you can always start with free when you realize, okay, you need more. You have maybe more complicated queries you run. That means your CPU load is getting a little bit in the exactly high, exactly. Thank you. Or you're running out of RAM. Maybe that could also be the case. Or actually, what's probably most likely is that your data set is getting too big, and then you need to upgrade, and then you can start with Pro, and then you can tier it up depending on what your needs are, and go from there. So it's a very easy entry point, and from there you get where you need to go. And it includes Neo4j Bloom, which is our visualization tool, Neo4j browser, and the data importer, which makes it super easy to get from a, let's say, CSV file to a graph database in the cloud. So we're going to see that. Yep. In the new workspace, you don't have to juggle windows. You see everything will be in one place, so that makes it even easier. It's free forever. So another big difference between, let's say, Sandbox maybe, and this one is that not after 7 days or so it's closing, but it stays with you forever. So as long as you use it, you can have it. And yeah, the link is in the chat. So if you want to create one, please go there. And yeah, what are we going to do today? Today we have a TED Talk data set, and with that we look into that. So yeah, I see you have already the overview. So the previous episodes are in this one page, and there is also code examples as well as more explanations to the previous episodes. So if you wanna know more, you can look here at these all these old episodes from previously.
It's quite a lot, right?
It's quite a lot in the meantime. So
how many are there? 54.
Yeah.
So it's on this page.
It's a lot, and we have all kinds of topics there. So if you no matter what you're interested in, I think you probably find something.
Yeah. Exactly. And so if you want to read about some of them in more detail, we put up a bunch of articles about them. Whenever I get to writing it up, we get a number of articles here.
Yeah.
And here's also the GitHub repository with all the data and all the articles as well. So we have all this in here too. So check that out. So that page is a good thing to bookmark. It also says when we are running it. So this week is the morning edition, and next week, or perhaps not next week because I'm on vacation, but the other week is then. So next week would have been an afternoon edition, and then we're doing mornings again. We are actually stable, so we're not pushing out, but we are basically alternating always the same way. So we should probably figure out if it's the even weeks or the odd weeks that have the morning editions and put this also somewhere of the year.
Is that work? Yeah, probably that. Yeah, well, yeah.
It should always work. Alternate because we never push it out. We always stay with our schedule.
Yeah.
Right. And if you want to check out future sessions, it's good to go to the events page where you see also all the other events.
Exactly. Yeah.
And then you can actually filter for live streams if you want to. Here, then you would see our live streams as well. Right. Cool. But this week it's TED time. So there was a time when I actually watched TED Talks like you would watch like YouTube videos. So back in the days, I watched like a ton of TED Talks. And I always enjoyed them. Not so much because of the like original content, or I mean, if I now look at many of these titles, they look a little bit like BuzzFeed clickbait titles. But usually they have a lot of energy. You learn something new, and you can also dive into new topics as such that you might not have spent time on. Right, and many of them.
Yeah, it's what it is before all this content was very hard to get to because no conference did recordings. Everything was at the place, so you had to be there or you missed it.
That's true.
TED was one of the only ones that recorded everything and then published it afterwards. So you were able to, even without paying, you were able to watch pretty well made.
Exactly, that's true. Yeah, you didn't have to pay. I mean. Exactly. So TED is really expensive to go there yourself. So I think it's like $5,000 to $10,000 or so a ticket or so. And to speak, it's invite only, of course. But actually, I always wanted Emil to speak at a TED conference. I think that would be a really cool talk on graph data and the impact of networks in our lives. But actually, remember Nicholas, who did the keynote for Nodes?
Yeah.
So I first, I think, saw him speaking in person at the TED conference, right? So he did like the hidden influence of social networks, basically, and how social networks present epidemics. And this was in 2010, right? So that's basically around the time when I started at Neo4j, as such. And that's why I first saw Nicholas. And you see now also that he's now 13 years older.
Yes.
Right. So that's where I saw him first, and then also got the book, the connected book from him and James Fowler. And so, for instance, that was something that I also got from TED, right? So which was really, really interesting from that perspective. Anyway, so you can think about TED what you want, but it was an early pioneer in recording informative videos, which is now something you get on TikTok and Instagram all the time. But they're actually well researched, and the people put in like hundreds of hours into their talks as well. Right? So that's also a lot of effort as such. So one episode or one session that I always liked is this one, When Ideas Have Sex, because that kind of talks also about the network aspect of ideas and how basically different ideas from different fields, if they come together, basically produce something new, and basically you encourage that, this kind of cross-pollination, then that's something that's super valuable, right? And so that's one session that I started to think about more recently, if that's actually something where large language models have an advantage over humans, because they have all this information they are trained on, and they have access to all of it at the same time, and then they can basically connect and combine all that information, right? So that's something that humans just are physically not able to have, like 500 billion or so pieces of information in their brains and connect them at the same time, right? So and so that's actually something interesting where we might see also not really new knowledge, but new combination of existing information coming out of large language models and such, right? So, and that's why I always like this one as well. So I was looking around the other day and found this project, which is actually pretty cool. There was an data wrangling with R project about TED Talks, and he did Anaya did a really good job at basically looking at the data, preparing the data, cleaning the data. So the data source is this Kaggle data set, which we're also going to use. And then she basically looked at the data, said, okay, what's in there? We have the talk title, we have the speaker, the main speaker, the number of languages, when it was filmed, which event it was filmed at, duration in seconds, description of the talk, ratings, which is an interesting bit because that's like an embedded JSON object, so that we'll have to extract as well. And then tags is also an embedded JSON object. So, and then she basically went through the data and looked at distribution and data cleaning and so on. So she basically looked at a little bit of what is it here? I think this has too many. Where was this actually? Oh, here, EDA. So where she looked at distribution of data fields and so on, right? So it was pretty nice and well done. So we'll probably also add this to the write-up as well.
Yes.
And I thought so we could take this data set, which has also tags and ratings, which is good for us for recommendations and correlating talks. And it has the speaker and the languages and then all the other stuff. So I thought that's a good one to use. And I just downloaded from Kaggle, which is here. So you basically see what I just mentioned. We have one CSV file with 8 megabytes of 7.6 megabytes. So number of comments, description, duration of the talk in seconds, which event it was filmed at, so which we can extract film date, its Unix timestamp, so we need to convert this into a proper datetime. Number of languages that the talk is given, and we can just store that. Name of the speaker that we can also extract as the speaker, of course, right? The name is basically the name of the speaker plus the title, so we can probably leave this off. Number of speakers, publish date, so recording date and publish date, ratings. So this is this JSON object which we need to extract. That's kind of a post-processing thing. And related talks. It's also a list of actually, does it actually have an ID field here? I'm not sure. So we might actually have to go over URL.
I mean, this might be interesting because this is hard-coded related talks. Maybe the graph database also can tell us the related talks without this.
Exactly. So that's, and we could compare this basically related talks from the dataset and related talks from the graph query. So speaker occupation, which is a lot of different stuff. Tags is basically just an area of text here. This is the actual title, URL, and number of views. And they're pretty large, right? Up to almost 50 million views, which is pretty interesting, right? So that's kind of the data, what it looks like, right? And this should give us some idea on what we want to, how we want to model it and what we want to do with the data and such, right? Super. So, and of course, I forgot to create an Aura database first, so we need to do this now. I click here on create, download my dataset, my credentials, which I call TED, and say, yes, I have copied this, which will create a new instance, and this fills up. Oh, by the way, Aura got a new design as well, so you now have no longer like the black and white thing and the switch on top, but you have AuraDB and AuraDS here side by side, and you can have instances and have the code examples here as well as a separate thing. And then now
That's
I need
nice.
to find my instance 01, which is this one. This is the newly created one, and we just renamed this to TED. And in a few seconds, it should be available for us to use. Cool. So while we're waiting for the database to spin up, one thing that I wanted to say is something that we need to do is basically in post-processing, we need to turn the film date into from Unix seconds into datetime for Neo4j. So that's something that we can actually look at. So if you say Neo4j docs datetime epoch seconds, we should get a docs page here. And if you search then here for epoch seconds, we can actually pass in epoch seconds to a datetime, and then it will basically generate the date for us. Right, so that's how we can turn the seconds into a datetime. So that's one thing that I wanted to show. And then the other thing that I wanted to show is epoch. Where is it? Actually, I can't see it. Epoch, yeah. So epoch 5 is now in Neo4j core product, epoch core. And if you want to convert this JSON from the CSV, this here, it would so data importer would store this as a string on the field, and we would basically take the string from the field and extract this and turn this into a JSON list of values, and then work with the data. And there's an epoch conversion functions. Where's conversion functions? Import procedures and functions. Mischillers is probably here. Is this conversion? Utilities. This conversion. You know what? We can just basically Google it. So epoch convert from JSON. So we can convert from a JSON map and from a JSON list, and then basically what we want to do is convert from JSON list, this one, where we pass in a string that contains a JSON list, and it returns me a list of objects basically, and then I can get information back. So in this example, create convert from JSON list 1 to 3, so I get 1 to 3 back, and then I can use this, for instance, to turn this into other objects. Or I can also have something that has map entries, then I get the maps back, and I can even use a JSON path expression to extract sub aspects of this as such.
Oh, there's a question from Luca. Why use datetime over timestamp? Are you storing it as datetime or just converting it to datetime when retrieving? I guess that's what we do.
Yeah, so I would store it probably as datetime, because there's also a datetime optimized index, and then you can use that also for datetime operations. And it's just nicer to access it from datetime, because then you have all the convenience functions like computed duration in days between something, or how long has it been since recording to publishing, or if you want to aggregate on the year of the publishing and things like that. So you don't need to use external conversion functions, but it's all built into the datetime type. And since Neo4j got datetime, I think with 3.2 or so, it's been actually quite convenient to use. The pure integer number for timestamps is more efficient to store, because it has less information. Because datetime also stores nanoseconds as well. But in general, it's more convenient to use datetime here. Cool.
Yeah, I mean, it depends what we want to do with it, right? I mean, if you just want to store a timestamp, then you can just, if you don't want to work with it in the temporal functions, but if you, like you just said,
you can also do it when you retrieve it as well. But then you can also just use epoch date format and things like that, or date pause on the timestamp. So if you have Aura running, then usually you should have only one button here. I had 3 because I had to test something before, but you can switch between workspace and the 3 buttons or the 3 individual apps here. So I just switched over to workspace, and if I open workspace, then it passes along my database URL, and my credentials should be here. If I still have the same thing in the, that's from our last time, in the clipboard. So now we can get started. So this is Data Importer. It also has Query and Explorer, which we'll look at later. But I would say we can get started. Load the file, and then we can start adding things. So we have our talk, which is important, right? Then we have a speaker. We can just drag out a node from the halo here. So this is our speaker, which presented our talk. Okay. Presented. The other thing that we have is also the location, basically, where it was, or the event that was filmed at, right, or recorded. What else do we have here? So related talks, ratings, and tags we need to separate out. That's already it, I think, right? In terms of what we can model here.
Do you want tags? Should it?
Yeah, but we can't do it. I mean, I can draw it in the model. Let's draw it in the model, but then we don't map it, basically.
Yeah.
So we have basically tagged here.
So we do this later just so people can see what we want to do, but the
model looks like. That's a good point. So we have talks tagged with tags, and we have also ratings. It is more like in reaction, actually, not in rating, right? Because if you look at these like funny or hilarious or something like that, or like long-winded, informative, and so on, they're more like reactions than.
That makes it tricky to what does it mean?
I mean, it means how people reacted to it, right? So that's, I think, what you can in the UI of the TED.
No. What I mean is like, what does it mean if somebody says funny? Is it good funny? Was it entertaining funny? Or is it,
so
it doesn't give any indication.
Funny. Yeah, I think they usually mean good funny. So, and then we have related. Sorry, that's another talk. Related. So that would be our model in the end that we want to end up, right? And what we have here in the file will give us these 3, and then the other ones we do with post-processing. Okay, what do we want? We want to have the comments. We want to have the description on the talk, the duration in seconds, film date, languages, number of speakers, published date. We need to save the ratings, and the tags, and the title, and the URL, and the views, right? So that's our. So it doesn't have a real ID, so we probably need to use title, I think. I see our ID.
Or URL. URL might also be.
Yeah, the problem is, what do we have in the related talks, right? So that's something that we need to see. We have, because they have here IDs, but the IDs are not in this file. That's kind of unfortunate.
That is true.
So I mean, we can look at perhaps in the Kaggle file here. Related talks. Can I open? No. Yeah. If we just look at sample. So these are the. I make it a little bit bigger. Oops.
Yeah, that's very small.
Okay, let's try it again. So this is description. This is our tags. This is here. This is, I think, the related ones. So actually, there's a lot of stuff in there, and They have a slug, which doesn't help us. They have the title in here, and they have only the image for it, because that's what they got from the on the website, right? So they don't have the URL as such. So I think what you can use is to hope is that the title is correct, and then go with that, right? Okay, but good to know. Good point, Alex. So our text will post-process the speaker. So you can extract the speaker, which is basically the speaker name and their occupation. And I think that's it. And here we have our main speaker, which we'll rename into name. And the occupation is just occupation.
Yeah.
So we'll probably check if you need to rename any of the other ones. Film date. So it's actually not the date time, it's actually date property. Number speakers, you can just return this into a speaker. And the talks title. Yeah, I think we don't need to rename any of these. And then the other thing that we had is the event here. Which is here.
Event.
All right, which is our event. And that already maps our relationship, so we don't need to do anything because it already selects the right bits here, which is good. So, and except for the name, which is just a combination of speaker and title, we have now everything mapped. Everything is green, so that's good. We can click on preview, and it shows us a model here. So this also looks nice. So the light blue ones should be the events, right? And they always have like a bunch of talks around them, and then we have speakers. And there might be actually some speakers that have more than one talk. So for instance, here this speaker, then it has 3 talks in the sample of the data set.
Yeah, that's good.
So total, it's I think 2,500 talks in this data set. So it gives us nice set of data as such, right? So let's click on run import, and it complains about the things in the data model that are not good. So let me just, because I kind of want to keep this. Ted. I really need to. It should not complain about it. It should just ignore it. But I think that's only a fix that they do in a recent version. That actually this is ignored. Whatever is not mapped. But I need to remind me to ask the team about it. So that imports the data. It takes a bit because there's a lot of like text data. But it took 11 seconds. That should be okay, right?
It's not so long.
It's not so long. So and you see it's 2,550 rows in a file as such, right? So and if you look at start exploring, it should show me our graph. And we can basically say our event gets an icon of do we have something for event? A mask. Let's say this is kind of our event, like a cinema. Our speaker is a person, and the talk is an what do we use for talk? A loudspeaker pep. We do this for the talk? I don't know.
Yeah, why not? Yeah.
Why not? Right. So you see already like the first talk, and Chris Anderson, the founder of TED, has probably a lot of talks, right? So in this data, or a number of talks. So I think they don't have the emceeing, it's the introductions to the conferences here, but he has like presented 4 talks himself, right? So it's probably one of the most prolific speakers because, as I said, it's invite only, and you usually get only like 1 or at most 2 chances to speak at TED.
Yeah.
So I'm not sure if Jane Goodall had more than 1 talk. There's another one. And then if you take the talks themselves and expand them, then we can see which events they were at. So basically we can see, okay, expand, recorded at, and then we see these have a number of event nodes here, right? TED 2002, TED Studio. Oh, actually, I didn't know that in 2002 they already started. We should actually look what was the first TED that they recorded. I think they have some really old ones as well. They look really like blurry and bad quality.
No,
but if you then take
but we can find out.
Yeah,
later.
you do a query about it, right? So, and these were all the talks that were recorded at TED 2002, right? What you can also do is we can just select 2 speakers here, for instance, like these 2, and say, is there like a shortest path between them? So is there an like connection between, did they meet at some event or so? And here are our 2 speakers, and it shows us like the path. So they're connected not directly, so they were at different events, but Ray Kurzweil was at both events, so he basically could have known each of them basically and connected them, right? So this is kind of a nice application of shortest path as such.
Yeah.
Right? Cool. So on with Flume, you can of course style and color and do different things here. So for instance, if you wanted to, you could give different years of the TED conference different colors, or depending on how often a speaker spoke, we can extract data here. But
exactly,
what we first,
make it bigger or smaller.
Yeah. So there's a lot of options how to exploit this here. But what we actually wanted to do, if you remember, we wanted to let's refresh this here, as we've learned recently that we need to refresh stuff here, right? So we can basically look at our graph here as well, and any of these nodes can be double-clicked and expanded. So we have basically a similar visual representation. But what we wanted to do, we wanted to take some of these fields and update them and extract them into data or nodes or things like that, right? So let's do one by one, and hopefully we can be quick about it. And let's start with film date. So we basically find our talks. I just type it out. It's pretty. Find our talks, and we set t.film date equals date of date time of epoch seconds of t.film date. So we take the film date, turn it into epoch seconds with an H. I pass this to date time and then extract the date portion of that, because date itself you can't construct a date from epoch seconds as such. And if you do this, it sets 2,550 properties, which is good. And then we do the same with publishing date, publish date. So that was quick. And if you rerun this here now and do look into this here, we see now film date is now a datetime. So if you hover over it, it should actually say datetime and not unknown. Date and not unknown. Okay, that's a bug. So we can report another bug back. But that's now a date, right? So because what we can do now is actually can say find us our talks and return t dot recorded. We have actually set the recording date on the event as well. That's something that we can now extract the year from this and then say how many. So now it's a question: do we want to order by number of talks or by the year? Let's say by year as sending, right? So we see some really old ones, which we probably need to look at if that's like artifacts or something where they really recorded really old talks. Because TED has been running since when, actually?
It's been around a long time. I don't know. Maybe they did some initial ones in.
It could be that it was like when a Club of Rome history founding.
Founded.
Oh yeah, because Chris Anderson took it over from someone else, right? And I remember this was the story, and then Chris Anderson took it over in 2000 or so. So it's been going for some time.
Yeah.
Right. So it's really interesting. 94 was one, and then 1990, and then 92, and I think, but what then
sure if they were.
1972 came from, I don't know, to be honest.
No.
The first one here. Anyway, so that's kind of one advantage of turning it into a date type. So we can just extract here and do this. So that's good. The next thing that we want to do is basically extract the tags, because that's an easy structure. So let's find a talk. Return t dot tags limit 5. So you see that it's just a list of a string of a JSON list, right?
Yeah.
So, and we can say epoch convert from JSON list. This should give us a proper list. So it looks the same, but it doesn't have quotes around them, and these are now real values here, right? So for instance, I can also say s tags and then size of return text size of text. So it's a real list basically. So we just do the conversion here, and then we in our return we see this is a list of 7 elements, 9, 10 elements, and so on, right? And what we can do now is basically take these tags, turn them into nodes, and connect the to talk, right? So we basically use merge, which reminds we should do create constraint.
Yeah, that's a good idea.
For t.tag require t.name is unique, and I hope I got this syntax this time right. Yes, I did. Good. So we create our tag on name, as we just said, right? So our property is name, our ID property is name, and this is almost right, because we have to turn this list into rows, right? So we basically do unwind tags as tag name. So basically takes this list and turns this into rows. So if you want to see what this looks like, you can just look into our here. So this is if I do an unwind on this here, unwind tags as tag name, to take all these lists and turn them into basically rows, and return tag name. Give us a long list of single values, right?
Yeah.
Of course, right. So it takes each of the lists and turns it into
individual
individuals. Exactly. Okay. Right, and we take this, use that to create our nodes, our tag nodes. So we create our tag name nodes, and we connect the talk. Merge does a get or create. So if the data already exists, it just returns it from the graph, and if not, it creates it. So, and if you run this, it should create a few dozen tags and connect the nodes to it. So if you get probably like another, 20,000 or 50,000 relationships in our graph. So, and it should run for a few seconds, and it created 20,000 relationships. And now we have these tagged relationships, and you see these tags now on a talk, and we could basically take one of these, let's say simplicity, and expand this, and you see all the talks that are connected to simplicity, which already gives that good data for recommendations, right? So we can say, okay, if I really like the talk, what other talk by tags is connected to this. So perhaps we should do this before we continue with extracting data. So we can say found our talk 1 that I just watched. So imagine we take this talk that I here just watched and see if it's actually in our data set. Title is when ideas have sex, return 1. So this is our talk, and we see it has speaker meta relay, recorded at tagged global, and is tagged with these tags, right? And then we want to see basically tags do we have here? And then what we want to see, which other talks share the same tags, basically, right? So that's a kind of T2, our other talk, or recommendation, if you want to see. And we want to actually count how often did the other talk have the same text as such, right? So we do an aggregation in between. We take T1, T2, and count star or count tag as frequency, and we can also take the tag names and return them list as well. And then we just say return T2.title, comma T2. We want something else. Could also extract the speaker, but let's take the title first. T2 title. Let's do the speaker. If you're on it, we can also do the speaker. T2 presented. Speaker, and we take the speaker name as speaker, and then we get the frequency and the tags T in tags, and we want to have the tag name. Let me say order by. Now we do the order by here. Order by frequency, descending, limit 5. Or yeah, top 5 is okay, right? So if you do all of the ordering and limiting here, that means we only work with nodes here. We don't never access any properties as such. And we only extract the properties of the speaker and of the text and all the other stuff after we selected our top 5. So it's much more efficient to do it this way, to do aggregations also on only on nodes and not on properties. And that gives us much more efficient queries as such. And we should probably create in, oh no, our title was our unique key anyway, right?
The title, yes. Or did you? Yeah, we did.
Talk title, yeah. I just want to see if that's if this is an index lookup here. So if I do this, then it takes how long? 3 milliseconds or so. And then we see inventor of electronic spreadsheet, Google, Genesis, Airbnb, the next web, toys and materials from the future. It sounds like fun talks if you watch an ideas talk just now, right? Or you can also, if you actually want to see something totally different, then you can just take the ascending order. So things that have nothing to do with this, right? And then you have basically other things. But I mean,
business.
it's business.
Funny.
Yeah. I mean, what you can do here is if you do it, it's an optional match. If you
business and idea, complete opposites.
But you can also have 0 overlap, basically, right? So if you make this an optional match, it should also give us 0 here as well. Let's see if this works. No, also always takes 1. Because this should be an optional thing then. But perhaps because I don't know actually why it's not starting with 0. But we could actually. So now my screen decided to refresh.
Oh, okay. I was just wondering if it's you or me, but you're back now.
I hope it's still showing, and I hope it stops going around in circles. Oh,
I see you. I can see you. Okay. I can hear you, and the screen is showing. So
okay, that's the most important thing. So that's our first recommendation query. Right? So we can basically get things recommended by overlap and tags, right? Which is already good. So the next thing that we want to extract is our
ratings.
The ratings bit, right? Return t.ratings limit 5, and we have again a list, a JSON list of elements, and it basically looks the same, right? So I mean, we can almost take our same thing that we used for. We could also constraint for rating. Let me do this. We called it reaction, right?
Sorry, yes, reaction, yeah.
Reaction name. So we added our constraint here so that all the operations are fast. And now we can basically do the same as we had before. So we can just look in our history for our, so it's actually command arrow up that you can go back in history here. So instead of extracting the talks, we extract the ratings. And this time, actually, let's look at this. Return ratings limit 1, limit 5. So this gives us JSON structures, right? So it's a list of ratings, and each of them has a name, account, and an ID, right?
Mm-hmm.
And unfortunately, we don't have these IDs used anywhere else, so we need to use the name as our as rating. So we get our rating, and then each of those has 3 attributes: name, count, and ID. And we basically say, or we call it here, let's call it reaction so that we don't mess it up, right? Oops. Reactions as reaction, and then we call this R reaction. Name is reaction.name. Then we take, we can say on create set r.id is reaction.id. Right, so we can at least save the ID property, and then actually, what did we call it? Reaction on, or I forgot, or rated, or
I think we said, well, we can decide what we want to call it now.
Or can also call it on, reaction on, or what do you call reactions on something? It's actually on, right?
Yeah.
Or reaction at on. English language is not our,
yeah.
first language.
Let's say reacted on is probably.
Yeah, I think. And then we also say on create set r dot count equals.
And now your relation, you have 2 arrows in your set by design.
Looks nice, right? But we only need 1.
Yeah, exactly.
So it's from the reaction to the talk, right?
To the talk, exactly.
So I hope I didn't misspell anything. So these are our reactions. We merge our reaction here, set the ID as additional attribute, and create a relationship. And then when we have the relationship created, when it's been a new relationship, it didn't exist before, then we set the count on this as well, right? So cool. Let's run this. Should probably create as many, like also like 20,000 relationships or so. No, it's actually 35,000 relationships. Right? So we have now this on relationship, and now you have here the funny reaction, and then we see like all these on relationships. And actually what we can do on the on, we can say actually our count should be our visualization here. So we see actually, can you see the numbers in here?
Yeah. Yeah. Okay.
So we see actually how often. So we can actually figure out what's the funniest talk actually. So we could say find our reaction, right? Name funny, right? And we just say, or the 5 funniest talks, right? So let's say order by return p, order by on dot count, we call it, right? Descending, limit 5. This should be our 5 funniest talks. Talk. Reaction, name funny. I just need to spell funny correctly, right? So we have basically these are our 5 funniest talks. So the first one is, what's it called? Oh, the education one, which was actually also the first one in the data set, which is interesting. It has 20,000 funny counts.
Okay.
Courageous. Unconvincing has only 300. I think people actually liked it. So it's not like on Hacker News where everyone hates everything. So long-winded was only 380, but so people seem to like it more than they hate it, right? So
Yeah.
what we could do is basically we could also like
Beautiful also.
like Anaya did. She actually classified the tags as well here. So she basically did classification in positive and negative sentiment of.
Okay, sentiment
Right.
analysis. Yeah, that's cool. Yeah.
So
yeah,
she basically
very
manually classified it, right? So she basically said these are positive and these are negative ones.
cool.
Right? So actually, what we can actually do this as well, because we can just steal her list here. Right, so we can basically just say match r.reaction where r.name is in, and then we just give it a list. Set r.negative. Right?
Yeah.
So it's added 4 labels, and then we just use the other list, and then we just set r.positive. Set. And the other ones are neutral, right?
Yeah.
And now we can see these are all like funny, ingenious, courageous, informative, persuasive, and so on, right? Jaw-dropping. These are all the positive ones. The negative ones are probably something like long-winded, confusing, obnoxious, and so on. And now we have basically done what she's done before as well. So we have now classified our reactions. So we could also basically look at what are the most positively reacted to talks. So we can find our talks and say they have a reaction, right? Reaction positive, and then return t dot or with t comma on sum of on dot count as total. And we can do total or average. It's up to us. Or average on dot count as order by return t dot title comma also collect distinct r dot name as reactions. Return t dot title reactions and total and average, and we sort this by total descending limit 5. What are the top? And here we would say R in reactions in access properties, as I just said, right? So the only time we need to access the properties for the relationship to get the count as such. Nice. So, and if you do this, then it takes how long actually? Let's find this again. Also a few milliseconds. And we see basically across all the positive ones, we see the, we can probably round the average because the numbers are so big. So we see all the positive ones are, stock of insight was also really good. That was of a doctor who had a stroke herself, and then she kind of describes how she experienced it and then how she recovered over the years, which was really good. So this is another recommendation, right? So we have now already 2 recommendation queries, right? So one is based on tags, and the other one is of kind of people's ratings as such. Right?
Yeah.
And the last thing that we wanted to pull out is basically the related ones. We are almost at time, but I think that's something that we still can do.
Yeah, because it would be interesting then to compare the two results, just to see.
So related talks, basically it's almost the same as with reactions. So we can steal the statement here, related talks as related, unwind related as talks, right? And then we just merge T2 or T1 as talk.title is
You need to write talk.
talk.title, I think.
You have you have T1 tag there.
Oh yeah, thank you. I've not seen that. And then on create set. So there's actually a trick. We can just say T1 equals, and then we just can take talk and extract all the attributes that we want. Actually, we can set all the attributes. Should we? Viewed count, slug. I think we can set all of them, basically. Perhaps not a speaker, but for the time being, we just set.
Yeah, just put it all in there. I think
and then we say this is there a count for related? No, right?
Count?
How you mean like a rating as such? No.
The view count, yes. Or
what I mean is how like what's their score for the relation for the related relationship.
Oh, I see. I don't think there is a score like this. No.
Related T1. So this is our talk. We created the related talk and then merge it on title, and then let's see if it also creates new nodes. Which feature is deprecated? So. What? Okay.
But it only
create two. It's not true. So it actually created our related relationships here, and now we have for each talk we have a related set. So what we now could actually do is go back to our original recommendation query that we had. Where is it? Here? No. Our tags. Here's our recommendation query, right?
Yeah.
And we could, besides our own recommendations, we could also say what are the original recommendations, right? And we basically just can say T1 related. And then we say other.title. So for each talk, we can also see related talks, basically. So, right. So this is our original, and then we can see, okay, this one was not in there, right? So this one is also not in there. So based on tags, it's not in there. What I think might be the reason for their related talks is basically what else did people watch, right? So because the watch information is not here, right?
Yeah.
So I think none of these are overlapping. So we could actually combine them, right? And say, hey, this is kind of an overlapping relation. So we have now 3 recommendations, right? So we have the one that comes from the dataset, we have the one from the tags, and we have another one from the like most positive talks, and we can combine them as well, right? So for instance, we could sort these by positivity or by higher rating from users as well, right? So there's lots of options that we can now do to turn this into an more real-world recommendation query. And as you can see, because it returns in 3 milliseconds, you can even put it on the website as live recommendations, basically.
Oh yeah, absolutely. Yeah.
Cool. And with that, I think we are out of time, and this was a really good one, really fun one. So I'll try to
this was
write
a fun, interesting data set. Yeah.
I'll try to write it up perhaps this afternoon or tomorrow. So let's see. I think I have some time tomorrow, perhaps.
Very good.
That would be good. Super.
Cool. All right. Good. So again, thank you for watching. Thank you very much, Michael, for taking us through the data set. Go to the community, go to Discord if you want to hang out and discuss stuff you've seen today or seen somewhere else, check out the page that Michael has up for the next live stream. I think it still says we are back on Monday next week, but I think you're out,
we have
right,
to
Michael?
fix that, right? Because I'm
So
out.
I have to fix that. So we are not going to be streaming on the 20th. I'll remove that back after 2 weeks. But in the meantime, there is another session I'll put up later this week, which is basically a small teaser today. On the 23rd, I'm talking to Adam Cowley about his Neo4j Visual Studio Code, an extension for Neo4j. So how he's done it, what it can do, and all of that. So that's happening next week. So until then, I hope to see you, and we'll be back in 2 weeks' time.
Take care, everyone.
Take care, and see you around. Bye.
Bye.